When astronomers first spotted the object now known as Three-Eye Atlas, it was nothing more than a faint smudge, a distant glimmer among millions of stars. At the time, nobody imagined it would become one of the most puzzling discoveries in modern astronomy. Three-Eye Atlas was catalogued on July 1, 2025, and right away it behaved differently from anything we'd seen before. Its trajectory, its brightness, and its composition all refused to fit the models. At first, researchers thought it was just another frozen traveler like Oumuamua or Borisov, ordinary interstellar debris, but the more we observed, the stranger it became. Over the past several months, both NASA and the European Space Agency have collected images and data from this object. These are not artistic renderings or guesses. These are direct observations from space-based cameras. And what they reveal doesn't match the profile of any known comet. Let's start with what we know. When the Hubble Space Telescope captured its first image of Three-Eye Atlas in July, astronomers immediately noticed an anomaly. Instead of a diffuse, cloud-like tail streaming away from the sun, the signature of every comet we know, Three-Eye Atlas showed a faint extension pointing toward the sun. That's not a small mistake or an artifact of the image. The same pattern appeared again in August and again when the Gemini Observatory followed up with ground-based imaging. In every frame, the bright core remained compact while a subtle, luminous spike extended sunward, the opposite of how solar radiation should affect a natural comet. Now, the European Space Agency has joined the investigation. The ExoMars Trace Gas Orbiter, orbiting Mars, captured the first off-Earth images of this visitor during its close pass on October 3, 2025. The object was around 29 million kilometers from Mars at the time, and yet the spacecraft's cameras detected a clear, compact light source with a faint but defined extension. In other words, ESA's data confirms what Hubble already showed. The tail, or beam, is real, and it's pointing in the wrong direction. To make things even more interesting, the Mars Reconnaissance Orbiter, equipped with the powerful HiRISE camera, also captured images at that same time. HiRISE is capable of resolutions down to tens of meters per pixel from Martian orbit, the sharpest camera ever sent to another planet. Scientists are still processing those images, but according to NASA insiders, the raw data already shows something highly unusual. Three-Eye Atlas doesn't appear diffuse or irregular like a normal comet nucleus. It looks compact, solid, and brighter than expected for its estimated size. That brightness tells us something important. It suggests the surface is reflecting sunlight far more efficiently than ice or dust normally would. In other words, it could be coated in something metallic or crystalline, materials that reflect light rather than absorb it. If confirmed, that alone would make Three-Eye Atlas unique in the history of astronomy. But the real shock came when the first spectra were analyzed. Using both Earth-based and orbital instruments, NASA and ESA scientists detected something no one could explain. Instead of showing the water-ice signatures typical of comets, Three-Eye Atlas is made mostly of carbon dioxide and carbon monoxide, roughly 90% CO2, 9% CO, and less than 4% water. No comet in our solar system has ever displayed that ratio. A comet that dry shouldn't glow this brightly. It shouldn't even survive this close to the sun without fragmenting. Yet Atlas remains stable, and it's only getting brighter. Then came the metallic data. Spectroscopy revealed an excess of nickel, pure, unoxidized nickel, with almost no trace of iron. Everywhere else in the cosmos, those elements appear together. They're forged side by side in stars and meteorites. To find one without the other isn't just rare, it's practically impossible in nature. That's why a growing number of researchers are beginning to consider that the material may not be natural at all. Harvard astrophysicist Avi Loeb has been one of the most vocal on this point. He's not claiming that Atlas is definitely artificial, but he argues that the data warrants serious investigation. He calls it the most interesting object since Oumuamua, and for good reason. The behavior, the chemistry, and the trajectory all point to something that doesn't fit our current understanding of comets or interstellar debris. Loeb and his team at Harvard's Galileo project have been analyzing the polarization data, the way sunlight reflects off the dust and gas surrounding Atlas. What they found is unprecedented: negative polarization. That means the light waves reflected from Atlas are oriented opposite to what's expected. In all recorded history, every comet observed shows positive polarization at large viewing angles. Atlas shows negative, a physical property we've never measured before. That single anomaly has enormous implications. It suggests that the dust or particles around 3I Atlas are structured differently from anything we've seen, possibly angular, metallic, or crystalline, rather than random grains of rock and ice. In short, the material looks engineered. Now, add to that its orbit. 3I Atlas travels along a path that's nearly perfectly aligned with the ecliptic plane, the flat disk where all the planets orbit. If this were random interstellar debris, the odds of that alignment happening by chance are less than 1 in 500,000. It's as if the object deliberately entered along the plane where it could pass by multiple worlds in sequence: Mars first, then Earth's orbit, then Jupiter. That's exactly how you'd design a survey trajectory if you were mapping or observing planetary systems efficiently. NASA's own orbital models show that after perihelion, its closest pass to the Sun, between October 29th and 31st, 3I Atlas will cross near Jupiter's orbit in March 2026. And waiting there will be ESA's JUICE spacecraft, currently en route to the Jovian system. If the geometry holds, JUICE could capture one last look before the object disappears forever into deep space. Meanwhile, NASA's Juno orbiter might also have a window to observe the flyby, depending on alignment. If that happens, we could have data on this object from multiple planets: Earth, Mars, and Jupiter, something that's never occurred before in astronomy. So what does Harvard think? Loeb's team has outlined two main possibilities. The first is that 3I Atlas represents a new class of interstellar object, a dense, carbon-rich fragment from the crust of an exoplanet that was shattered eons ago. That could explain the dry composition and metallic surface. The second, far more controversial hypothesis is that Atlas could be a technological relic, an artificial construct designed to travel between star systems, possibly using sunlight itself as propulsion. In that scenario, the beam of light observed pointing toward the Sun might not be a tail at all, but a controlled energy interaction, a way to recharge or communicate. While NASA remains cautious, Harvard's analysis has begun influencing how other observatories frame their data. The European Southern Observatory, the Lowell Observatory, and independent astronomers have all noted similar brightness irregularities and phase angle anomalies. The data from Mars has only strengthened the case that this is not a typical comet. Still, not everyone agrees. Some argue the unusual features may result from unknown chemical reactions under extreme solar conditions, reactions that produce strange scattering effects and optical illusions. But even if that's true, Atlas remains an unprecedented natural laboratory. It's showing us physical processes that simply haven't been documented before. Now, the world waits for NASA's official release of the high-rise images, the sharpest, most detailed views of 3I Atlas yet. According to NASA's schedule, these images were taken on October 2nd, but the release was delayed due to the U.S. government shutdown. Once processed and cleared, they'll give us our first direct look at the object's structure, its texture, and its reflectivity. A single high-resolution image could answer a dozen questions at once, or raise 100 new ones. If those images show a smooth, reflective surface, it could confirm the metallic hypothesis. If they reveal vents or jets, that would support the natural comet explanation. Either way, the data will push astronomy forward in ways no one anticipated. Because whether 3I Atlas is a natural wanderer or something far more complex, it's already rewriting our understanding of what's possible in interstellar space. For the first time in history, we are watching an object from another star system interact with multiple planets. And it's happening right now within our reach. with cameras orbiting Mars and instruments ready on Earth. If it's natural, it's teaching us new chemistry and new physics. If it's artificial, it's teaching us something even greater, that we may not be the only engineers in the galaxy. Either way, the message is clear. The universe still has surprises left. Stay curious, because the story of 3i Atlas is far from over. When the new images arrive, everything we think we know about this visitor could change once again. And when the universe decides to speak, we should all be listening.